provide high smart shear value. It doesn't help that the asphalt slips off the first time a truck turns or brakes. So it needs to have a proper shear adhesion as well as a tensile adhesion so that the asphalt doesn't come loose. It must provide composite action where applicable. Composite action in layman's terms, which is doing that, then that system must be able to try and reduce a little bit of it. It doesn't help that the system comes off after 10 days and one Friday. In terms of the application benefits, we must be able to work over a wide range of temperatures. It doesn't help, for example, in Canada, that we can only waterproof 7 months of a year because 5 months are too cold. We must be able to work in complete and extreme conditions. The coldest temperature we've ever worked at in Canada, which has nothing to do with the Philippines obviously, is minus 30 degrees centigrade. So we can work at any temperature where people can provide warm enough clothing to work. But of course, in this part of the world, we're up on the upper end of the scale, so we must be able to do and execute at 30 or 35 or even 40 degrees centigrade where applicable. The system is unique in the sense that it will set and dry in between 45 and 60 minutes. That means after 45 or 60 minutes, you can come on with your asphalt or your rail ballast or whatever you need to do. We go as far as to say that after 45 or 60 minutes, if you wanted to remove that, you would have to come with jackhammers and take it off, because that rapid setting is what allows us to reduce the possession. In other words, to allow you or another to carry on doing what they need to do so that we don't hold up the workstations, and we also have spray applied formulations. Interestingly enough, if we use cold spray applied resin, the material doesn't change any viscosity as the temperature drops. Typically with conventional polyureas and polyurethanes, if the temperature is low, i.e. 5 degrees centigrade or 0, you will have to heat those resins to get to the right viscosity. This system, even at minus 20, comes out of the can into the pump, so there's no appreciable change in the viscosity. And that also means that we don't have to worry about storage externally in cold weather. There's very little waiting time between successive coats. If I use this surface that I'm standing on as a bridge deck analogy, we put the primer on at 8 o'clock, at 8:30 we'd come with the first layer, at 9:30 we'd have the second layer, at 10:30 the third layer, and at 11:30 we would be able to give the surface back. So what we're trying to do is reduce the possession to give back the owner his or her surface as quickly as possible, irrespective of what the ambient conditions are. So at minus 20 we will give it to you an hour later, or at plus 30 we will give it to you in an hour later. It doesn't matter. We must make sure that if we have installed the thing in a place like the Philippines where there's lots of rain, as long as we have that hour or that 45 minutes, we are not worried about the rain. We do a lot of work in Hong Kong, and in Hong Kong, for example, the Met Office is very, probably the best. When they say it will rain at 2 o'clock on Tuesday, they normally write by about 15 minutes. In Belgium and Canada, when they say rain on Tuesday, then we have to work which year they're talking about, because they get it so bad here that the system must be able to withstand that rain after 45 or 60 minutes. Cool temperatures don't phase us at all. If there is a drop in the temperature, the catalyst that we apply to the system will allow the system to sit at all by external or ambient conditions that have dropped. I don't know what the coldest temperature here is in the Philippines, but even if it does drop to 5, it's of no interest to us whatsoever, because the system will still cure in the 45 or 60 minutes that we stay. And the rest, as we said before, when we've done the waterproofing, work doesn't stop then for 2 or 3 hours. People carry on doing the work. We're not really worried. Unless somebody willfully wants to damage the system, then there's no real issue for us to worry about there. The rapid sitting means that repairs can also be effected using the Puma systems. In other words, a lot of our work that we do is not necessarily new. It's coming in and working between the limited hours that are given to us when the bridge is closed for a couple of hours. And the rapid handover means that there is financial gain for everybody. The quicker we can give back the surface to you or to another, the better it is for all parties. So there is financial gain in using systems that are handed over quickly. Also, the cured PMMA or the cured Puma, once it's dried, is not hazmat. It can be disposed of in the normal way that we dispose of household fashion. So we don't have to make the precautions of getting rid of the material once it's cured. Most importantly, the performance benefits well in excess of the concrete's tensile strength. That means that even after an hour, if we did a pull-off strength, the concrete would fail in tension, it would fail cohesively because the bond strength is well in excess of the tensile adhesion or the tensile strength of the concrete. What the system is very unique at is crack bridging. You know that crack bridging is very, very important. If we have something that is broken and there's ingress of harmful substance in that, then it's not really waterproof because obviously the harmful substance gets through those cracks. It has exceptional chemical resistance. I'm not saying that it resists everything because it doesn't resist repeated solvent. But things like oil and gas, and also not oil, well, oil and gas as in petrol gas, as the Americans say, the system is capable of resisting that. And there's an enormous amount of certification that will lend theory to that. It's very tough, so it's not easily damaged by subsequent actions. In other words, when we put it down, as I said, if you wanted to take it off, you'd have to come with jackhammers and take it off. The system is really easily repaired. We know that somewhere along the line we will have to do some kind of repair. And what we want to be able to do is do those repairs quickly and rapidly and get back the surface in a short amount of time. So it makes ideal opportunities for repairs or rectification of existing or damaged waterproofing. It has an exceptional global track record. We work in countries all over the world. We do a lot of work in Canada, we do work in Vietnam, we do work in Israel, we do work all over the world in a very short amount of time, and we've got some very, very heavyweight global track records. And we've learned over the years that in external situations in such as bridge, we only use Puma, we don't use anything else. We have a long history of problems in the past where we've not really satisfied all the criteria. We've now found that with the Puma system that we've got the right thing. A real fact that you know about, but I'll just repeat, is that if you're going to have cold weather, that's when the concrete will contract. So in even coolish weather, if it goes from 20 to say maybe 5 or 6, that concrete will contract. And that is when the system is really called into question. And what we did determine when we first started going into North America, we asked a lot of the engineering firms what their criteria was. And the only thing that everybody agreed on was that we should have a good crack bridging. And the crack bridging, according to ASTMC 1305, is in our view probably the most significant crack bridging, because they take those samples that you see there and they open and close them at minus 26 degrees centigrade for a month. And you have to show that you can bridge 2 or 3 millimeters of crack. So the real issue, and really what the focus of the presentation is, that we can present something like that. That is a real live case scenario in Toronto on a suspended slab where they called us in and said, there's a crack in the system, and we commissioned 16 cores, and all 16 of the cores showed very, very clearly that the waterproofing membrane there, 2 millimeters thick, was bridging cracks that were quite significant. So that is the real issue for us. This is what our business is about, to prevent the ingress of harmful and deterrent substance into a situation like the bridge deck. And this is really quite critical for us. Like everybody else, we have to make sure that we have all the certification. I learned in all the years that I've been traveling around that the first question I'm always asked when I walk in to talk about bridge deck waterproofing is, do you have a BBA? Because if you don't have a BBA, you can actually remove yourself from my office. But in every other country, not everybody goes with a BBA, so we have all sorts of certification in Russia, we have ASTM, etc., etc. We have a veritable smorgasbord of certification, because in every country that we work, we have to show independent verification. Very quickly, because I'm running out of on the steel or the concrete deck, and we put asphalt on top, which is what you see on the left. The next one is we do a lot of rail bridges where we'll waterproof the deck and we'll put the ballast directly onto the deck without protection board, i.e. the system is flexible enough to resist that. And then the third one is where we actually use a wearing surface which is in place or in lieu of asphalt. So instead of putting 5 or 10 or 15 centimeters of asphalt, we put 8 to 10 millimeters of a wearing layer which incorporates waterproofing, wearing layer, and of course the non-slip resistance for operational activity. 6 to 7 millimeter thick wearing course, which we lock in afterwards with a flood coat to make sure that we can do. And we've done all this in the space of a few hours, ready for use 1 hour later. Now that we're doing the waterproofing and the wearing layer. There we are again in New York on the Tremco Bridge. This was an interesting one. This is a bridge of 109 years old. They've had no steel reinforcement. What you're looking at there is a steel cage, and then every year they'll come along and they'll put the asphalt on, which you can see on the bottom left. And of course course, as soon as the snow plows go on, then this whole thing gets removed. So they gave us a few hours and we came in and we put it for 6 years. This is Hong Kong. We're probably the only system that's approved by the Hong Kong Highways Department, and this followed a 4.5-year monitoring of a sample in the Lion Rock Tunnel. So now when you do these systems, you have to show that you can actually resist 4.5 years of wear and tear. So we do every night, when it's not raining, we do 50 or 100 or 300 square meters to resurface roads and bridges in Hong Kong. This is in Nanchang in China. This is a pedestrian and a cycle bridge. Obviously different colored aggregate to show which is which. And we also have a lighter duty version for pedestrian things. So this is in Denmark. This is at the Hong Kong Jockey Club. So these are surfaces that are designed to be governable or operationally safe, i.e. non-slipping wet and dry conditions, but to give us all the waterproofing and the wear resistance that is necessary. In the rail sector, I realize that we are not in the rail sector yet, but just something I want to mention is to sell any bridge deck waterproofing in North America in the rail sector, you have to comply with the AREMA indentation. AREMA stands for American Rail Engineering Maintenance of Way. What they'll do is they'll give you 3-inch crushed granite. You will load that into a 0.6 meter diameter steel drum to 300 millimeters, and at the bottom they will attach the drum to a stainless steel plate with the membrane on, and then before he goes home for his donut, he will turn a switch on. At 28 kips, that leg will pulverize for 2 million cycles. It takes about 7 days, and then they'll come along and they'll have a look to see if there's any perforation or laceration. And it's quite an onerous specification because they say you shall seek, you shall find, and you shall pass, or you shall fail. And what they do is they come along with water and they put the water on an area that they can't see and they run an electrode. And if it comes as much as a half an ohm, you fail. So we failed 3 times using MMAs and PUs. It was only when we switched to Puma that we realized that we got the result. And so there you're looking at another $8,000 well spent because now we have the AREMA indentation. And what the significance here is that in your road, whether you have asphalt or whether you have trucks or whether you have anything, is you have a real tough, durable membrane on your surface, be it steel or be it concrete, because if it can withstand the AREMA, I promise you it can withstand everything else that you will chuck at it. So it becomes a big part of our business. We are the preferred waterproofing company for most of the Canadian people. We put the system down at 3 millimeters to withstand all the ballast ingress, and we do most of the work there by hand. Here they're working at -7 degrees centigrade, and after 2.5 hours they give it back. When we come into your kinds of production, when we're doing waterproofing under asphalt, then we do new bridges and we also do old bridges. And that's an interesting photo because that's typically what we see all over the world. And what we're looking at there, without being very specific, is a polyurethane coating. And we make a lot of money out of fixing up polyurethane. Some of these systems are from our companies as well. So we're not pointing fingers at polyurethane. The problem with polyurethane and polyureas has become very commoditized. 10 years ago or 20 years ago, 5 or 6 or 20 companies made it. Today, 500 companies make it. And everybody competes for the same business. And to get a competitive edge, I'll put something in, he'll take something out, we'll do something. And there's a great example of what happened in Beijing Rail. Just before the Beijing Olympics, they came along and they said, we want to use polyurethane. They decided that they would farm the polyurethane out to find the same surfaces. And today they have an hour's presentation about why you can never ever use polyurethane again, because it's a catastrophe. More than 70% of the stuff is in trouble. That's not because polyurethane is bad, it's because people will do something to gain a competitive edge. And that's where and we had a 100% success rate on the shear and tensile adhesion values. Here we are in Canada. We always apply after we put the membrane down, we always put a tack coat on, and the tack coat is so that we can broadcast aggregate to provide some key. So that in other words, we can provide a bit of extra shear for the asphalt when the asphalt goes on top. As I said, the system can be spray applied as well. Here we are spraying onto bridge decks, steel bridge decks in Canada. Here we are in the UK doing it by hand. In the UK, this is the famous Dartford Tunnel in the UK, doing this at night by hand. Here we are also in the UK. Always after we've done the system, we'll do spark testing or holiday testing to make sure that we don't have pinholes. We typically get, if we're lucky, we get 5 or 10 on a job of 500 square meters. So it's a very, very dense system that doesn't really give us any problems. Here we are in Australia. We've made a big breakthrough in Australia with some of the senior people, Vic Roads, RMS and everything like that. So this is big business for us now in Australia. And we also do, as we mentioned, because this is a tunnel conference, we also do a lot of work in tunnels. I talk specifically about cut and cover tunnels where we have access to come along and blast the surfaces we're doing there, and then come along and spray on the vertical as well as the horizontal surfaces. So tunnel waterproofing, if we can resist the arena, we don't have to wait days and days and anything. 1 hour later we can come along and we can actually install waterproofing. So we've got quite a few tunnels that we've done on the and sometimes are not practical from a time point of view. So we've developed also, which is a BBA approved system, a rapid setting repair mortar that we can pour in, and that an hour later we can go home. And most importantly, what we have is dimensional stability. We don't have shrinkage and we don't have cracking, because it's an MMA-based system, and we typically provide 70 megapascals or 70 newtons in 60 minutes. But it will provide that with zero absorption, zero shrinkage, and zero cracking. So it's become to you. Thank you.